Let's look at 12. Let's use these x values to create this function here. That seems simple enough. If we have a 0 going in here, 4 to the 0 power, you could be using your calculator on this too, by the way, but I'll do this by hand. 4 to the 0 power, right? Anything to the 0 power is 1, so boom, right there. Plug in a 1, 4 to the first power, that is 4. 2, 4 squared, wait a second, doesn't really fit there. Well, we'll make deal with that. We'll just imagine it's up there, I guess. Now, what about these other ones? Negative 1? Well, you raise something to a negative power, it's going to make it a fraction. So 4 to the negative first would be 1 over 4 to the first, which would be 1/4. Negative second power, that'd be 1/16. So really, really small right there. So there's that function. Respect the asymptote, right? Now it says graph the inverse. If I'm graphing the inverse, remember, inverses are just reflections over that line y equals x. So I'm going to take all these points that I had here and just reflect them. So if I'm at 0, 1, now I'm at 1, 0. 1, 4 is now at 4, 1. And then if we had 2 and then 16, now it would be 16 and 2. So we're way out there. How about these ones here? That was negative 1 1/4. So 1/4 and negative 1. And then a 16th and negative 2. Looks great. Now the asymptote's vertical here with this red graph. Now notice this. Describe the domain and range of the inverse function. So this one right here in red. The domain, all the x values that get used here for the domain would just be all of these ones here, right? Because we have a vertical asymptote, we get all these values and going and going and going forever out there. So our domain here for this function would be all positive real numbers. Or you could say something like this. I was just saying it in symbols. I don't care which way you say it, either this way or that way. Now what about the range? Now when it comes to that range there, now we're dealing with all the y's, and if we look here, the same graph, we get all these y's going here forever because of the asymptote, and because this graph is increasing, we're going to get all these y's, oops, let's try that again, we're going to get all these y's here going on forever in that direction. So it seems to me like our range here is going to be all real numbers, positives and negatives. And we could write that symbolically just like that with one of those funky looking R's, right? So I don't care which way you write it there either. Alright, so the last two problems here, number 13 and 14, I'm expecting a lot of problems on these ones because over the years students do struggle with this stuff. A couple things you have to remember about writing an inverse. An inverse is not an opposite. So if you're looking at this and saying, ooh, inverse, 4x, and then, ooh, opposite, minus 4, be careful. I'm pretty sure this is not it. Yep, I know it's not it. So don't just do the opposite of what you're seeing right there. That's not really what the inverse is. The inverse is a set of operations that would get this x right here by itself. Just like there's a set of operations here that happen to x. So we have to keep those order of operations here in mind. So notice what happened to x here first. Is the first thing that happened to it is we divided by 4 and then we added 4. That's what this order would tell us there by the way they arranged these this expression. So if we're trying to write our inverse, we need to have a set of rules that happen to x in the proper order that would undo this x. So if we divided by 4 and then added 4, the first thing we would have to do is subtract 4. And because I want to subtract 4 first, I'm going to put that in parentheses. Because whatever I do after that, I want to subtract by 4 first. So now, going back up here, notice what happened to net x here is it was divided by 4. So we have to do the opposite of dividing by 4 and then multiply by 4. I'll accept this expression, or I'll accept it if you decide to do the distributive property on it. Either one of these work. Let me give you an alternative strategy here. We talked about this in class. It's very similar to that work that we just did earlier, where I had you guys write the inverse by switching the x and the y. You can do that here. Remember, this is just saying y equals x over 4 plus 4. So if we swap the x and the y, now I have x being equal to y over 4 plus 4. Now my job is to get y by itself. To get y by itself, we need to subtract 4 first, and then multiply by 4. But since this is already here, we got to multiply by 4 just like that. So there would be our inverse there once again. 4x minus 16 would be our inverse function. So notice something here. It's not just the opposite here. Okay, it goes a little bit deeper than that. Let's take a look at the next problem. This time I wanted you not only to give me the inverse by writing it like we just did on the last problem, but now I also want you to graph it. I'd like you to look at this from two different perspectives here. The first way you can do this is, how about we get graph the inverse first. Notice the first graph here, it's 3x minus 1. It's a linear function. It's in slope-intercept form, so this should be pretty easy for us to graph. The y-intercept was negative 1, and our slope is 3. 1, 2, 3, to the right 1. Rinse and repeat, or reverse, and there's our line. Okay, so inverses, let me clean this up a little bit. That's better. So our inverse is the reflection over the line y equals x, right? So if this is our line y equals x right there, then what we can do to get our inverse is just swap all these x's and y's. So let's just start with this point down here. Isn't this at negative 1, negative 4? So let's go to negative 4, negative 1. This spot right here, the y-intercept, it's at 0, negative 1. So we need to go to negative 1, 0. Here's at 1, 2, so go to 2, 1. And then 2, 5, go to 5, 2. There's your line. I'll just draw it. Witness the artistic work. Beautiful, right? Okay, so now when it comes time to finding the graph, if I look here closely at this, this is going to be pretty tricky for me to just write the equation here. I can nail the slope down pretty good, can't you? The slope here, pretty easy to spot here. Rise over run. Looks like we're going up 1 into the right 3, so our slope is 1/3. But notice that y-intercept definitely does leave a little bit to desire. I'm not quite sure what that one's going to be. Okay, so what's our other alternative here? Well, the other alternative that we have with this problem is we're going to have to write the inverse based on looking at this function here. So our inverse function can be found by writing down the process that it would take to get this x by itself. What happened to x first? Well, we multiplied by 3 and then we subtracted 1. So to get x by itself, we have to add 1 and then divide by 3. So let's add 1 and then divide by 3. So there's our inverse function right there. Do you notice that we said the slope here on this graph was 1/3? Can you see it right there when we take the 1x and divide it by 3? And it looked pretty good. I mean, notice that the y-intercept here would have been 1/3, so that looks about right there now, doesn't it?